Hello. So now we are going to look into another measure of dispersion, which is called the mean deviation. Now, mean deviation is defined as the arithmetic mean of absolute values of deviations from a chosen origin. Now, this origin may be mean, median, or mode. So, you'll have a look at the deviation of each observation from the given mean or median or mode. Absolute values would mean that you are looking at it by ignoring the signs of it, and then you find the arithmetic mean of these deviations. So, for raw data, the formula for mean deviation about mean would be summation xi minus x bar, and these straight lines on either side is called the modulus operator, and this basically means you're looking at the absolute value of the deviation, so you're ignoring the signs. Okay, so summation absolute value of x minus x bar whole divided by n, where n is the total number of observations. Similarly, mean deviation about the median can be written in a similar manner, where inside the brackets or inside the modulus operator you have got x minus capital M, and M stands for median, right? So find the deviations from median M, take its absolute value, sum it up and divide by n. So it is the arithmetic mean of the absolute values of deviations. Now, these are the absolute measures, and the corresponding relative measures would be the coefficient of mean deviation about mean and coefficient of mean deviation about median. So, simply take the value of the mean deviation about mean and divide it by mean to get a coefficient. So, remember, since the numerator and the denominator have the same units, your coefficient is a pure number. Similarly, coefficient of mean deviation about median, just take the value and divide it by median. Now let's have a look at how to solve and find the mean deviation about the mean and the median using these formulas. I'm using the same numbers and calculating both the values. Right? So the first step that you have to do is to calculate the mean of the individual observations. So the total x value, summation x, turns out to be 450, and n is 10 because there are 10 observations, so you get the answer 45 as your mean. To find deviation, you will subtract x minus 45. So the second column here gives you deviations from mean, and the modulus operator, like I said, means that you will write the deviations by ignoring the signs. So 20 minus 45 is minus 25, however you ignore the sign and write 25. 23 minus 45 is minus 22, ignoring the sign we write 22. Similarly, 15, 13, 1, 6, 11, 12, 12 and 33 are the various deviations of various observations from the mean 45. When you sum it up, you can see that it comes up to 150. So the mean deviation about mean, we are here, will be 150 divided by 10, as the number of observations is 10, which is 15. Now, using the same individual observations, if I want to find mean deviation about the median, my first step would be to find out what is the value of the median. Now we know that when we have individual observations, the position of the median will be n plus 1 by 2. So it's 11 by 2 and the position is 5.5. So the median value is between the fifth and the sixth number. So the fifth number is 46 plus, so we have got the fifth number and we have a 0.5 remaining. So that is 0.5 times the difference between 51 minus 46. The difference between the sixth and the fifth observation. Okay, this is the same as finding the average between the fifth and the sixth terms. Okay, observe that it is absolutely necessary that when you're finding the median, your x values are arranged in an ascending order. Right? It is, the question was given to us with the x values already arranged, so we didn't have to make any extra effort. So as you can see, your median value comes up to 48.5. So over here we calculate deviation from the median value of 48.5, and the modulus operator means that you are going to look at the absolute value. So 20 minus 48.5 is minus 28.5, but ignoring the sign, because we only want the absolute value, I am writing it as 28.5. Similarly, 23 minus 48.5 is 25.5, 30 minus 48.5 is 18.5, and so on. We will get 78 minus 48.5 as 29.5. If you add it up, you have got summation of deviations around median, which is 148.0. 148 divided by n, which is 10, you get the value of mean deviation about median as 14.8. Similarly, to find the coefficient of mean deviation about median, divide the mean deviation about mean, which was 15, by the value of the actual mean. So 15 by 45, you get the answer as 0.333. Basically it's 1 by 3. And to find the coefficient of mean deviation about the median, take 14.8 divided by the actual median value of 48.5. So the answer is 0.3052. As you can notice, the two values, the coefficient of mean deviation about mean as well as median, are quite close to each other. So that actually does indicate that the mean and the median themselves are very close to each other, which means that our distribution of the values is very close to a normal distribution. We will discuss this later, of course, in more detail. But I just wanted to draw your attention to the fact that the values are quite close to each other. When the skewness of a curve, distribution curve, is less, you will find these values close to each other. So now, we'll have a look at one more example where you have been asked to calculate mean deviation about mean and the coefficient, its coefficient, as well as mean deviation about median and its corresponding coefficient when you have a continuous frequency distribution data. So by continuous series, I mean that your values are given as per class intervals. Your class intervals are from 0 to 10 and to 10 to 20, 20 to 30, and finally 40 to 50. The corresponding frequency is given in the second column, F, as 5, 15, 17, 11 and 2. The total frequency, of course, adds up to 50. Now remember, let's have a look at the formula for mean deviation about mean in the case of continuous frequency distribution. So I am representing that as MD, capital MD stands for mean deviation, and the subscript X bar, I'm talking about this formula over here, means mean deviation around the arithmetic mean X bar. And the formula is summation F times X minus X bar in absolute terms divided by capital N, where capital N means the total number of observations or the total frequencies. Remember, column 1 and column 2 are the data that is given to you. You need an X variable. When you have class intervals, your X variables given in column 3 are nothing but the midpoint of the class. So it is lower limit plus upper limit divided by 2. So you will get your X values as 5, 15, 25, 35 and 45 respectively for each class. Now, to find deviation about mean, we first need to understand what is my X bar. Remember your formula for X bar, summation Fx divided by summation F. So the fourth column is the product of 2 and 3, that is Fx, and you get the total as 1150. So we get our mean as 1150 divided by 50, which is your total frequency. So 23 is your mean. Now let's calculate deviation from this arithmetic mean. So column 5 gives you X minus 23. So 5 minus 23 is minus 18, but for mean deviation we are looking at the absolute values. Ignoring the signs, I will write it as 18. 15 minus 23 is minus 8. I'll write it as 8. 17 minus 23 is minus 2. Ignoring the negative sign, write 2. 11 minus 23. Oh, I'm so sorry. I said it wrong. Very sorry. X minus 23 is 5 minus 23 is minus 18. 15 minus 23 is minus 8. We are ignoring the negative sign and only writing the magnitude. 25 minus 23 is positive 2. 35 minus 23 is 12. 45 minus 23 is 22. And if you look at the formula, we need summation of F times the absolute deviation. So column number 6 is column 2 into column 5. So 5 into 18 is 90. 15 into 8, 120. 17 into 2, 34. 11 into 12, 132. 2 into 22, 44. And when you sum it up, you get the value of 420. Putting it into the formula of mean deviation around mean, you will get it as 420 divided by 50. As you can see, the value is 8.4. And to find the coefficient of mean deviation, divide 8.4 by the actual mean of 23 and you get the answer as 0.3652. Now, using the same question and the same data, I am also going to calculate mean deviation about the median. So, over here, columns 1 and 2 are the data that is originally given to us. You have your class interval 0 to 10, 10 to 20, going on till 40 to 50, and you have your frequencies which add up to 50. We have to find the median. To find the median, the first step is to calculate the cumulative frequency. Remember, we are adding it downwards so that we know that number of observations less than 10 is 5. Number of observations less than 20 is 5 plus 15, 20. Number of observations less than 30 is 20 plus 17, 37, and so on. Now, the position of the median will be determined by capital N by 2, where capital N is the total number of observations, 50 in this case. So we know that the 25th term will be our median value. Since this is a continuous frequency distribution, you will need to remember the formula for median, that is L plus N by 2 minus M divided by F into C. I'm basically talking about this particular formula, right? So the median class is the one shown here, 20 to 30, because the 25th term, check for the 25th term in the cumulative frequency. As you can see, it will fall in this class because 37 is just larger than 25. So your median class is 20 to 30. L is the lower limit of the median class, so we write 20. N by 2 is 25. M, as you can see here written in green, is 20. It is the cumulative frequency till the median class. So that will be 20. Divided by F is the frequency of the median class, 17, into 10, where C is the size of the class interval. So the median value comes out to 22.9. Let's have a look at what the formula for mean deviation about median is. Symbolically, I'm writing capital MD, which means mean deviation, and the subscript is capital M, which means mean deviation about the median. So this is my formula. So as per this formula, I need to find the sum of the product of frequency times deviations from median. So let's just scroll up. We need x values, and x values, like earlier, are your class midpoints, upper limit plus lower limit divided by 2. So I get 5, 15, 25, 35 and 45. To find deviations, subtract x minus 22.9 and report its absolute value. So 5 minus 22.9 is minus 17.9. I'm writing it only the figure, ignoring the sign. 15 minus 22.9 is 7.9. 25 minus 22.9 is 2.1. 35 minus 22.9 is 12.1. And 45 minus 22.9 is 22.1. So that is the deviations. Absolute value of deviations is column 5. And column 6 is frequency, that is column 2 multiplied by the deviation column, column 5. So you get the values as 89.5, 118.5. Similarly, 11 into 12.1 is 133.1, and so on. All of which adds up to 421. If you remember, this is the numerator. 421 is the numerator of my formula, divided by 50, so that I get my mean deviation about the median as 8.42. To calculate it or convert it into a coefficient, divide 8.42 by the median, 22.9, and you get 0.3677. Once again, the mean deviation about mean as well as mean deviation about median, the values are quite close to each other, which actually indicates that the mean and median are not very far from each other, and the skewedness or the asymmetry in our distribution is quite less. Finally, let's move on to the merits and demerits of mean deviations. The merits are on the left hand side. They are rigidly defined. They are easy to understand, simple to calculate. They are based on all observations and not unduly affected by extreme observations. And finally, this is a measure which has sampling stability. Okay, but there are a few demerits. One of the most important ones is the first one mentioned first itself, that ignoring the sign of deviations makes no mathematically logical sense. Because if you want to describe a data and how it is distributed around, say, the mean or the median, you are interested in seeing whether it's spread out more towards the left hand side of the mean value or the median value, or to the right hand side. So ignoring the signs of the deviations actually ignores some important information that can give us an idea about the kind of distribution that we are dealing with. Another big demerit is it is not useful or capable of being used for further algebraic manipulation. And a technical demerit is that it gives more weight to larger deviations and smaller weights to the smaller deviations from mean or median. So these are your merits and demerits of mean deviation. Remember, mean deviation can be calculated from any chosen origin. Most popularly, we talk about mean deviation around mean and median. In certain cases, you might even decide to calculate the mean deviation around the mode of the data. If nothing is mentioned in particular, you've just been asked to calculate the mean deviation, it refers to mean deviation around the arithmetic mean. That's a tip for the exams. Okay. I hope it's clear. The example that I've taken is directly from the guide that you have with you, and I have used the same data to show the calculations for both types of mean deviations, so that you can compare and have an idea about how the values may differ. That's it. Thank you.